Hello everyone. I know it's one of the latest session in this room, so I will be brief as possible as I can. So my title is How do you decide where your customer was? I'm gonna be talking about location analysis and our Hadoop structure in Turkcell. My name is Burak Işıklı. I'm a senior software engineer in Turkcell in Business Intelligence Technologies department. I'm planning to present with Erkan, but Erkan broke his leg and he couldn't come here. So a little bit about Turkcell. Turkcell is one of the leading company in Turkey. It's the second largest telco company in Europe, and there are 34.5 million subscribers in Turkey and 71.5 million subscribers in 9 countries. And it is the first and only Turkish company ever to be listed on New York Stock Exchange. Let's skip that advertisement and start with presentation. So our Hadoop journey started in 2013 with a small cluster. Currently, 15 terabytes data processing for each day, and 6 terabytes data are collecting. In order to do that, 350 jobs are running in this cluster. We've done a lot of things in this cluster. For ETL part, CDR analysis, log processing, and so on. Analytic processing, we've done fraud analytics for SymBox detection, let's say, clickstream, and recommendation engine. We've done a data lake implementation in namely customer journey project. But in order to these projects, which architecture do we use? Which architecture should we use? This is the abstract view of our architecture. Logs are collecting by Unix or internal tools. And we are extracting data from relational database using Tuna. Tuna is our internal tools on top of Scoop. To transformation the data, we use Peak, Hive, Perl, and Spark. After that, there are 3 options for us. One option is load data into database and then report from there. Or we can send data to external system, let's say rule-based systems, and do something with that. Another option is we send the data to alarm systems and trigger according to some rule. It's very important when you are dealing with fraud analytics, especially. What is our issues? We are using HTTP 2.3.2. So the default Python version is 2.6. And Spark IPython works with Python 2.7 or higher. Do you know what is Spark IPython is? Everyone know? Okay. And we have security and auditing issues. For instance, copying data by masking. This means that our number one security rule is when you developing something with data, you had to be used by anonymized data. So In order to do that, when you are transferring data from production cluster to development cluster, you need to anonymize them. Another issue is even some business customers aren't allowed to see some column. It may be your telephone number, social security number, your name, or etc. It's regulated by SOX compliance, so it has to be done. There are lots of incubating projects, and some of them is graduated. But we are still trying to do these compliance according to our rules. So I'm gonna give you a couple of use cases and then give you an explanation how we done this. So first use case is location analysis. Find the subscriber location using cell information. That's the scary part is coming. When your telephone is on, your telephone sends signal to your operator. Even you are not talking. So we are collecting these data to process them and then find the subscriber location. This is not the exact location, but it's almost near you. This data size is 11 billion rows and half a terabyte per each day. And it takes 2.5 hours to process. And we use Hadoop streaming, and we choose Perl programming language, and that's it. So how these logs are generated? So this is a figure of CDR or XDR generating. Subscriber calls to someone, and then XDR is generated. Signaling data is called XDR. And when the conversation is ended, it's ready to ship anywhere you want. So FTP or HTTP process is started after that and put into our HDFS cluster. This is a recursive process. We need to collect these data all the time. But why do we not use Flume? Why do we use FTP, HTTP, or any other Unix tools? Because Flume wants to install on the source side, install something to create channel. And we are not allowed to install anything on server side because we don't mess with these servers. And then we decided to use FTP, copy, or any Unix tools. But one thing is important, rsync and FTP work serial. So you give a file list to FTP process, and then it transfers one by one, not parallel. It's very slow process because of that. And we decided to some modification and to parallelize it. And another important thing is XDR or CDR's data size is changeable. It may fit into the data block or not. It's depending on the hours, on the busy days or holidays. So we need to combine these data to fit the data blocks before the putting into HDFS. But we've done an experiment for this. We put these data into HDFS cluster without any modification, without anything else. Just copy and put, copy and put. And then another process started to transform, started to combine these data into proper format, to usable format. But if you work with Java, you are familiar with these exception, out of memory exception. We've got this exception. This is simple solution is increase the heap size, right? But again, it failed with a different message. Failed relocation of scalar replaced objects. It's related to Java 8 bug. Garbage collection is started before process ended. So this is why we are still continuing the old architecture. Why we are continuing old architecture. But this is only the collection part. After that, because we use Perl, all the transformation depend on us. How so? Joining. When you use Hive or Peak or any other kind of tools, you need to type join, and that's all. Inner join, left outer join, or another. But when you are using Perl, you need to implement yourself. So how do you do that? When in the mapper phase, you split data into two parts, header and trailer. Header part is consistent join column, and if you are trying to join more than two files, then file name. And rest of the file is at the end of the line. And that is the joining part. In the reducer part, you add a couple of if-else condition, and that's it. That's the location analysis in our first use case. Now you need the subscriber location, where your subscriber is, which city, which district, which neighborhood. This got a lot of attention in our company, and we know that this is like a tree in the forest. There are a lot of upcoming projects in near future. But also, data size is growing too fast. Within 6 months, our data size grows twice, 1 terabyte to 2 terabyte in 2014. So, and moreover, we are not using LTE in this very moment. At the beginning of April in this year, we are started to use LTE Advanced, but at this time, we are not using. So a lot of more data is coming. We know that. Who has ever been in Istanbul? Raise your hand, please. Okay. If you've ever been in Istanbul, you may see this picture in reality. Our worst nightmare is crossing the continent. And there are lots of options to cross the continent, but by bus, by ferry, by car. But people who live in Istanbul decides what is the best way to do it. And there is a bottleneck in the bridge. When you are using your car and crossing the continent by car, you have to enter this traffic jam. But in our system, we don't create a bottleneck. So how do we do that? How do we, without creating a bottleneck, we create a system and scalable? I said relatively small cluster. In 2013, we have 1 master node and 4 data nodes. And we are using Hadoop version 0.23. It's an old version. And after the upgrade, we've seen that our jobs has improved. Per job is taking 212 minutes to 204 minutes. And without any modification, without any changing number of reducers, number of mappers, and other thing. Just move the data, move the code, and run it. That's all. So we also see that when we upgrade it, there is a lot of much disk to use. So there are lots of more upcoming projects, which is one of these. Next use case is industry-specific analysis. This is a competitor comparison. There are lots of shopping centers in Istanbul, and customers need to view their point of view based on age, income, or any other demographic information you want. And the user interface is on the slide, as you can see. This is an urgent request. As you can imagine, there is receiving email urging we need to do this as soon as possible. But how? We use Perl before that, and there is a file. So do we re-implement in this situation for Hive, in Hive or Peak or Spark? But it takes more time. What else? The solutions come with Hive external partition. We used, so the pipeline is like that. Per job generates a file, and then Hive using that file as an external partition, as an input. And that's it. We now have a queryable data. Sorry. Next use case is movement index. So in this project, subscriber journey is provided to determine and analyze with which they transfer between these. So in briefly, which customers do you use? Which customers do you use plane? Do you use bus to transport, to change their cities? So airline companies want these data because they need to know which customers using airline, which is not. We know the change of location, and we know the base station coordinates. So first thing is find out the closest cell using these coordinates. This is a simple Euclidean distance. For those who do not remember, the formula is on the slide. But it's not important. So, in the Hive query, this is just a cross join, right? Just cross join and create another table. And then after that, you need to combine these data into together. So all needs to be done is simple another query. Everything will be fine. Let's ship it, right? Just one problem. Hive doesn't find the partition column, but we already created a partition, so we know, and we do not wrong typing or anything else. So this is a bad joke. This is like a bad joke. But what can we do that? When you try to do in Hive, you can face it in a lot of ways. So this is just another bug in Hive. When you are using Parquet, you have to use this workaround solution. Just setting the index filter to turn off to able to use this data. The permanent solution is in Hive 2.0, but since we do not upgrade this system, we need to use this parameter. And be careful this parameter, because this parameter is, when it's turned off, you can't use column indexes, and it may affect your performance. So, is it enough? Is that all you can do? We've done a lot of descriptive analysis, as I told you, but we need to do more predictive sides. So, it's the ongoing projects. So we need to use Spark ML to predict our user location. In the description analysis, okay, we find the subscriber location, but what is the next location? What can be next location? And another thing is, this is a batch processing. We need to change this process into in real time. And the last thing is, we trying to query on Hadoop using Spark SQL, Impala, Presto, any other tools you can name it. So this is a teamwork. I must thank my colleague Caner and Uğur. I'm just telling this story here. And thank you very much for listening to me. Is there any question? Yes.
Yeah, right, thank you. I'm quite interested in knowing more about how you do the comparison between the shopping malls, although you don't know exactly the location of the different individuals.
We do know the exact location when the customers is in the shopping center because we have indoor cells.
Right. Okay. That makes sense. Thank you.
Any other question? No? Yes.
When you were computing the Euclidean distance, was that over quite small geographical distances? Like, how large a region was that? The only reason I ask is because sometimes in the past we've looked at computing distances, geolocation distances, over quite large spaces, and then the Euclidean distance is error-prone because it doesn't actually account for the curvature of the Earth. But I guess you're really talking about quite small geographical distances, so it really doesn't matter.
No, I'm talking about whole Turkey, but you can do spatial analysis for this purpose. We just do some basic experiment for this, but this is enough for me. Any other question? So, thank you.